Now that you can identify acids and bases, let's take it to the next step. Let's look at how acids and bases neutralize each other. So this is another type of reaction, an acid-base reaction. You can also be a double displacement reaction, but we just call it acid-base reactions. So you have this diagram here that's really quite cool. If you look at this key, a single little dot is a hydrogen ion. A dot with a big black dot is a hydroxide ion, and then this upside down Mickey Mouse looking thing is a water. And if you look down at the questions, question number 1 asks you to look at beaker A. How many H's are there and how many OH's are there? So notice there's 1, 2, 3 H's, and there's 1 OH. And I'm going to do a greater than sign there just so that you can see there's more H's than OH's. And if you go down to question 4, it's going to ask you, is this beaker acidic, basic, or neutral? Well, all solutions have H's and OH's. All solutions. I always have a student who thinks, oh, you can only have one or the other. No. All solutions have hydrogens and hydroxides. Now, the amount of hydrogens and hydroxides determines whether or not it's an acid or a base. Well, we know that H is associated with acids and this is associated with bases. Well, if you have 3 H's to 1 OH, this is an acid. So now let's look at B. B has 2 H's, and there's 1, 2, 3 OH's. So this one would be a base because there's more OH's. And in this one, you have 1 H, you have 1 OH, and so they're equal to each other. And this is by definition neutral. We have the same amount. And that takes you through the first 6 questions, okay? So number 1 says, based on the information presented, draw reactants and products that form when an H and an OH ion come together. They're just wanting you to show that an H and an OH makes a water. Not a big deal, okay? What would happen if solutions A and B were mixed? So if you go back up here, solution A has 3 H's. 3 H's, okay? So I'm going to write those out. I suppose I did not need that 3 there, huh? Okay. And beaker B has 2 H's. So a total of 5 H's. Do y'all agree? And then we've got 1 plus 4. We have 4 OH's. So in a neutralization reaction, you always get 2 products. Every single time when you have an acid and a base, you make water and you make a salt. Always. So put the water together, what remains is the salt, okay? So if you put beakers A and B together, I want you to notice that you would make 4 waters. And remember, everything else in those beakers were waters. And you'd have 1 hydrogen left. So I guess you could argue that that solution would be ever so slightly acidic. Classify. So in 2, what would this be? It would be an acidic because there was an H. Can a neutral solution contain H and or OH's? Yeah, both. All the time. All the time. And as far as, is it acidic or basic or neutral? It just depends on the amounts. More H's, acidic. More OH's, basic. Same amount, neutral. There you go. All right, so let's get into a little bit of math here. I promise you it's not horrible, okay? How many moles of H ions would you have if you have 2 molar HCl, 1 liter? Well, if you have 2 molar and you have 1 liter, don't you have 2 moles of HCl? So in a picture, that's HCl and HCl. Well, what do those break down into? You get hydrogen ions and you get chlorine ions. So how many moles of H would you have? You would have 2 molar. Do you agree? Or 2 moles of H? All right. Let's look at the next thing. Let's look at the next one. If I can erase here. I is struggling. How many moles of OH are needed to completely neutralize 2 molar HCl? Well, we said we have 2 moles of H, so we have 2 of these, right? Don't I need 2 OHs to make those water? So in order to neutralize 2 moles of H, I need 2 moles of OH negative. So look at the next one. How many, behave, eraser, there we go. How many moles of OH are in 0.5 molar NaOH? Well, if I had 1 of these, I'd have 1 OH, right? I only have half, so I have 0.5 moles of OH. The next question is, well, how many moles of H would I need to neutralize it? The same amount, right? We want them to come together to make water and nothing else. So this one's a little tricky. How many moles of OH are needed to completely neutralize 0.5 liters of 2 molar HCl? Well, remember, 2 molar means 2 moles per 1 liter, and I have half a liter. So don't I just have 1 mole of H? How many OHs would I need? That's right, 1 mole. All right, so just remember that they need to become water and neutralize each other out. So one of my favorite equations is, I call it M1V1 M2V2. You can substitute in A's and B's for acids and bases. It really doesn't matter. You can use this equation to make dilutions or neutralization reactions, okay? And it's pretty easy to use. It's just a little multiplying and dividing. So we use this to calculate molarity or volume, and you're going to do this on Monday. On Monday, you're going to do a titration. In your beaker, you're going to know that you have HCl, and you're going to know the starting amount. I believe it's 20 milliliters. And up here in your burette, you're going to have a base, and you're going to know its concentration. And you're going to put this into the acid until it neutralizes. It turns color. It's really cool. And you're going to know how much base it took. So you're going to know volume. You're going to know molarity. You're going to know volume. You're going to calculate molarity. And that's what we're going to do in these problems. So when you read, I want you to notice how the numbers are linked together. How many milliliters of 2 molar? So that's how many liters volume of 2 molar? 100 milliliters of 3 molar. All right, so first and foremost, notice how those numbers go together. Doesn't matter which side of the equation you put them on, just keep them together. Now, here's the other thing I need to point out to you. I absolutely love this equation. If and only if, are you paying attention? These are in a 1-to-1 ratio. What do I mean by that? If I were to write this reaction, HBr, okay, you don't even have to write the water and the sodium bromide on the other side. You could just stop here. Do I have 1 OH for every H to make water? Yes, I do. So as long as you have a 1-to-1 ratio, this is fabulous. I'm going to show you in a minute what you have to do if it's not 1-to-1, okay? So let's set up our equation. We want to know what volume of 2 molar will neutralize 100 milliliters of 3 molar. And by the way, you don't have to change the milliliters to liters. It works just fine. It's kind of cool. So you multiply here and you get 300, and you essentially have 2V. Divide by 2 and you get 150 milliliters. Okay? So let's look at the next one that we can no longer see because I wrote all over it. So the next one says, how many milliliters of 2 molar, so those are going together, are needed to neutralize 20 milliliters of 4 molar KOH? Notice we have HBr, KOH. HBr and KOH are in a 1-to-1, so we can use this equation. So we have 2.0 V equals 20 times 4. I'm not worried about sig figs, you guys. 2V equals 80, so V is 40 milliliters. Agree? And the next one's basically the same thing, okay? you've got, see if I could just sneak this in over here. You've got 50 and 3. I'm just getting rid of say figs, don't mind me. And you want to know what the molarity is of 150, right? So you multiply here and you get 150 equals 150. Well, when you divide 150 by 150, you get 1.0 molar, all right? Now, these next three are what do you do when they're not one-to-one? You have to think. And there is actually a long version where you use volume and molarity to go to moles, and you do a mole ratio and all that jazz. And it probably is the safest way to do the problem, but it kind of confuses kids. So let's do the M1V1, but we need to think, and I'll show you what I mean, okay? So we know that volume and 2 molar go together. We know those two go together. I would like you to notice you have HBr and you have magnesium hydroxide. Now, are these H's and OH's in one-to-one? No, they are not. What does that mean? I might have 2 molar magnesium hydroxide, okay? So that means I have this twice, right? Everybody agree? When this breaks down, don't I get 2 magnesiums and don't I get 4 hydroxides? 4. So the concentration of OH is not 2, it's 4. So you're going to do volume times 4 is 3 times 100. And you wind up with 300 divided by 4 and you get 75. So again, why did I not use 2? Because if I have 2 molar, I get twice as much. So you have to double it. So notice again, you still have HBr and you have OH2. They're not in one-to-one. So I have how many milliliters of 2 molar will neutralize 30 milliliters of 4 molar. Now again, what do I need to do to that 4? Every time it breaks down, I get 2. So you have to multiply by 2. So 80. So you wind up getting 240 divided by 2, and you get 120 milliliters. Now let's look at this last one here, okay? See if I can get rid of it all. So on this last one, this one's really tricky. H3PO4, MgOH2, okay? So I have 3 molar H3PO4. Every time it breaks down, I get 3 H's. So I don't have 3 molar for the H. I have, 3 times 3, 9. So I have 50 times 9 equals 150. And again, there's 2, so I'm going to put in a 2x for molarity, okay? So over here, you get 450, 300x, and when you divide, you get, I believe that's 1.5 molar. And that is the end of that worksheet. Again, this purpose of this worksheet was to walk you through how do you know if something is acidic or basic based on molecules, number of H's, number of OH's, how do you neutralize, how do you do the M1V1 equation. And on Thursday, we will do pH and OH and solving for hydrogen and hydroxide concentration. So if you have a good background on all of this stuff, it's going to be pretty easy. Now, the other assignment you need to do today is it's an online simulation. You have a handout. You have to access 2 different simulations. Seriously, read my directions. I spell it out exactly what you need to do. But one thing I didn't talk a lot about, but it is in the lab if you read everything, and that is litmus paper. You have red litmus paper and we have blue litmus paper, okay? This is not in the simulation. This is just something I want you to know about. If you put red litmus paper into a solution and it stays red, it is either neutral. Neutral will not change the color, or it's an acid. But if you put red litmus in a solution and it turns blue, it's a base, okay? If you take a blue piece of litmus and it stays blue, Well, it's either neutral, because neutral will not change, or it's a base. But if it turns red, it's an acid. So if it turns blue, blue for base, BBB, okay? They go together. If it turns blue, it's base. If it turns red, it's an acid. If it doesn't change color, it's either because it's neutral or blue stays blue because it's a base. Red stays red because it's an acid. So walk yourself through those and then take a look at my answer key on that lab. So the point of the simulation is, number one, to just start looking a little bit more at hydroxide and hydrogen ion concentrations, how they relate, what are the relationships you see. It'll really lead up to what we do on Thursday. And the other half just defines strong acids and bases versus weak. And it has literally nothing to do with pH, and it has everything to do with how it breaks down. A strong acid completely breaks down in solution. A weak acid doesn't. And we're not going to do the ugly math this year, but just trust me, it leads to some ugly math. So go ahead, work your way through this one. Again, I'm not grading this or the other worksheet. I am going to grade your lab. And let me know on Thursday if we need to go over anything. Thank you guys for being good sports. Bye.